We're out here in sunny San Diego on August 2nd, 2022. We're actually here demonstrating an underwater communication system. As well, we wanted to briefly talk about the technology, give a quick technology overview, and then just kind of talk about the history of our free space optics technology and how it could apply to different Navy opportunities. The technology is about 22 years old. A lot of our products are in 5th generation. We've done a lot of work with ONR, Oplog. We've done a lot of work with NAVWAR. We've done a lot of work with the NIWC LANT, NIWC PAC, SOCOM, Air Force Research Labs, and a bunch of other groups to develop the technology. Generally, free space optics initially was a niche technology to solve niche problems. And that's where special operators, for example, did not want to keep radios in contested areas and be detected with their radio signatures. So we created a system like this, which is a non-visible, basically walkie-talkie, connects a tactical headset to it, and then 2 operators can communicate voice communications bidirectionally up to about 1 kilometer apart. We have, on top of the bidirectional voice communications, we have data communication systems. This is an example. Our systems operate as a 10100 base T Ethernet, basically wireless connection. So we give up to 20 megabits a second on a 10100 base T Ethernet connection. It's a physical layer device, meaning you don't have any special drivers. You can just plug and play with IP devices. If you're carrying encryption, if you're carrying any kind of TCP/IP traffic, it operates irrespective of the traffic on the system. We've designed systems that work in UV and blue, which is actually what we're demonstrating here, the underwater communication system, up to visible, to near infrared, all the way up to mid-wave and long-wave infrared as well, just to solve challenges from our different customers. We also have maritime systems, ship-mounted maritime systems capable of 10 to 12 nautical miles for ship-to-ship and ship-to-shore communications. We're working with NIWC PAC. They're actually testing the systems at sea. They've been working up to sea state 4 and providing a stable 20 megabit a second link between ship and shore. We're working on land system communications that provide a 360-degree omnidirectional free space optics antenna between command elements. Again, being able to work in conjunction with RF systems, and also if an RF denied or RF contested environments, you can go to an optical communications link and avoid having your RF compromised by adversaries. Anyway, so today we're demonstrating an underwater communications link through our U10 systems. They're basically not much larger than this, primarily developed for the oil and gas industry. They provide, again, that 10100 base T Ethernet connection underwater down to, the systems are rated down to 1,000 atmospheres, and provides up to 20 megabit a second link underwater. In clear water, we've tested the system out to 30 or so meters. NAVWAR has actually done testing with these systems as well. And in with high turbidity and bay water, the range is reduced, but not a tremendous amount. So right now we're actually streaming a live video feed, IP camera feed from one of these links to another underwater. So this is a very straightforward and pretty elementary setup. Tripod. This is actually a pool tool for putting, just pool cleaners in the water. We have our node attached to it. That's a U10 node underwater, about 1 meter or so. He's connected through an underwater cable here. And so this is the power system we're currently using. So this is a small lithium-ion battery pack, a 7.4 volt battery pack. The system you see down there only runs on about 5 watts. So even a small battery pack like this or a USB pack will power the system for a significant amount of time. We have just this off-the-shelf IP camera here. This is a standard Axis IP camera connected through an Ethernet cable into our system. And this is what is providing that link to the other side where we're actually presenting that IP video. then the pairing modules on this side. Again, this is the pairing side. Again, another underwater cable coming through. This box just is a basically same mirror of what you saw there. It's just a breakout with power and other things to run this side. And then there's an IP connection here, and that connects to the computer here. And it's a little faded on the sun, but this is actually live video coming from that IP camera. And if you want to focus on that for a second, I'll walk over and show that it's a live feed. We don't add any specific delays in the system. So this is, yeah.
Yeah, because underwater blue transmits the best. So yeah, so once we pull them out and the underwater demo's over, you can just see the blue.
Some cool things for the UV actually that might be of interest to you is we do have the capability of reconciling range very carefully. So our systems can operate essentially as like a closed loop rangefinder system, where basically we're timing every bit, but we can actually get range down to centimeters between nodes. And as well, we have the capability of reconciling angle of arrival. So for example, for a USB recovery, as it's coming onto the vehicle to recover, we can actually tell you real time what the range is closing, and we can tell you what the heading is as it comes on board.
Where is in that cone?
Right.
Can you also, if you line up on, say, a QR code, be like, okay, I need to orient myself like this. Well, like that's all the software, but I can line up on a QR code and then get so it flashing out and seeing it back.
Sure. I mean, you could run use us at that point as just a communication medium.
Yes. Yeah. What we've done is you actually, instead of it would be reflectors.
Yeah.
So you have 3 different reflectors on 3 different parts, and then you can triangulate the distance and the signal from each. So absolutely, just a slightly different manifestation of it.
And then this is a small package. This is the system we delivered to the let's see, it wasn't Navwar, it was Spawar, I guess, when they were delivered. But this is basically a single LED, single receiver. It's about a 3-inch cube, and this is the system would work well underwater to the same distances as what you see underwater right now.
Do rangefinder, double S.
We also do diver comm systems. So this is basically a retrofit underwater diver light.
Absolutely.
We've actually added our technology to with a connector that would mate to the mask and allow divers to actually talk underwater bi-directional.
I have like 6 slides on that topic.
Using the light comms. For this
I think Russell
purpose, we actually use blue. We've experimented with blue,
but it's like
UV, kind of in that sweet spot for our communication wavelength. And then there's certain applications where green might be more applicable depending on turbidity of the water. So it could be that a comprehensive system may have multiple wavelengths depending on water conditions to be optimized for the communication link.
Could you run, say, something like this underwater with 3 or 4 different frequencies? Can you change each of the LED frequencies if you wanted to, or those are hard plugged?
They're hard plugged, but we can actually drive a multitude of different colors.
So you can actually run them through and say, yellow is better today than green is today, or whatever.
That's exactly right. You could almost have almost like a spectrometry or some way to measure turbidity, and then optimize for color, and then the receiver,
and then change that as if you're in sort of a transition period coming off the coast where you go from this to this,
right?
With blue, it doesn't work. Find that you can fine-tune that frequency of light to get better for you as part of your package.
That's right, and the beauty of that is that the receiver really just needs kind of a wide filter on it to cover the variation. So we only have to vary the transmit emitter. We don't have to.
But then at that point, it's a matter of switching to this frequency.
Yeah.
Okay. It's a common. Okay, we're retune now. Okay, now we go. We're good.
And some of our special operations customers, they have centralizing a system where it's basically blue or green underwater. And we have a sensor that detects that it's out of water, and then it'll go straight to infrared.
Okay.
As soon as they breach water. So then the near infrared just provides a very good, the link budget. The atmospheric absorption of near infrared is very good for our systems. So yeah, it's again we're dealing with 20 years of technology development. We've had TRL-7 systems, fully deployed systems. So not just R&D by any means. As well as the data communications, the systems also have a voice communications channel used for set up, and also can also be used for bidirectional voice communications. So, you want to do a test with me?
Sure.
Okay. If you can grab this headset here, and it's short. 1, 2, 3, 4, 5. I'll go to the other side. Okay.
Hello.
Hey, I can hear you.
I can hear you too.
So, we're demonstrating bidirectional voice communication as well as the IP data running underwater.
Very cool.
Very good. So one thing that's really cool is because we are just basically a physical layer Ethernet connection, even at test and evaluation events, you could plug us right into a tactical radio. We interop with MAN-A tactical radios. We interop with SATCOM. Just an Ethernet cable between those devices and our underwater system will provide throughput communication link with no software, no drivers, nothing special. It's just a plug and play, basically wireless Ethernet cable.
Who else is in this space?
It's a good question. So there's a couple people that play in the underwater space. Again, the oil and gas industry is expansive, and so they're more into infrastructure type systems, larger, higher power systems, whereas we kind of focus on more of like something you would integrate with UUV, USB, systems like that. The nodes you see here, you can see the battery pack. It runs on about 5 watts, so it's an extremely low power system. In the above water space, there's a few players that do the laser communication, long range gigabit Ethernet, which are generally going to be more expensive, backhaul type systems. And we were kind of looking to operate as like in that radio replacement space, where relatively low cost, low swap, to kind of work on par with radio systems.
If I may make one comment on that,
Yeah.
I think it's very important to note that when you get to the Gig E and high data bandwidth systems, they usually use extremely not eye-safe lasers. And we actually had an incredible test with Johns Hopkins APL, basically, and every time something came between their link, they're like, turn the laser off, it's going to burn a hole through the sail, or something like that. And so actual installations are challenging when you're putting through that much power in one small space, and then you have to supply that power as well.
And we try. He's exactly right. So we use an LED, which is basically an incoherent source. So instead of like basically a collimated, high power focused laser source, we diverge quickly into an incoherent source, which spreads quickly. And what that means is not a single amount of energy focused at a high point that could do eye damage. So we design our systems primarily for eye safe out of the aperture, with no NOHD, no standoff requirements, under class 1. So that means, we understand our operators. They may not be paying attention. They may accidentally have this up by their eye. There's no potential for, eye damage there. We can drive laser systems. We can drive high power systems. We just generally try to focus on the more eye safe aspect of things. And then if our customer says we need to go up to space, then, we just turn the power up.
And we have.
Yeah. And optical systems are kind of fun in the sense that they're not much unlike radio antennas. So if you have like a full wave radio antenna versus a quarter wave versus an eighth wave, there's trade-offs, but you get range for each one. Our system's not much different, where as you scale the size, we scale our operational range and capabilities as well. So we have systems maybe about 4 times this size that are capable of, that's the maritime system, capable of going ship to ship up to 10 to 12 nautical miles. And providing basically ship to ship battle group communications. We're hearing from a lot of different customers. Again, NIWC PAC is utilizing the systems for interop with other friendly countries, and they're actually preparing their systems to go to RIMPAC in 23. NIWC LANT is working with our systems, and just evaluating them, understanding them. We're working with the Marine Corps Warfighter Labs, we're working with AFRL, and just a bunch of different entities on a bunch of different projects. And I think what started as kind of a niche technology for niche problems is starting to become more mainstream. So you start to hear a lot more about operation in contested environments and having to operate in RF denied spaces, and that's where we're a really good fit complement to existing technologies.